Hello. Okay, so this right here is our FSM for the vending machine. This is the B input that was 5 rupees, and this is the A input that was 10 rupees. And this is the switch for deciding if we want an Oreo or a Kokomo. If this is 0, then this light, which is the Kokomo, that will turn on, and if this is 1, then we'll get an Oreo. So if I insert a 5 rupee coin after each cycle, then I'll get to the first state, and then to the second state, and then finally to the 15 rupee state, after which I'm getting an Oreo because our input is 1. If I switch this to 0, then we'll get a Kokomo, as you can see right here. So if I switch the coin to a 10 rupee coin, then I'll directly go to the 10 rupee stage and to the 15 rupee stage, after which you can see that the FSM resets back to its initial state, the ideal state. And you can see that if I turn this back on to 1, which means the Oreo, we get this light LED. Okay, so let's look at the state diagram. So this is the state diagram. We have four states. The initial state is the idle state, and or the reset state, uh, when no coin is inserted. If a 5 rupee coin is inserted, that is the B input is 1, then we move on to the Q state, that is 5 rupees. And then if another 5 rupee coin is inserted, then we move on to the R state, which is 10 rupees. We can also go to that R state by directly inserting a 10 rupee coin, because we have two options. So then the A input will be 1, and we'll move on to the state. After the state, if a 5 rupee coin or a 10 rupee coin is inserted, we move on to the next state, that is the S state. And similarly, if we are at the Q state and we insert a 10 rupee coin, that is the A input, we move on to this state. So when we move on to this state, we are going to take the input from the switch, so we can decide which snack we want. So you can see, as shown in the FSM machine in the circuit, that we were resetting it back to the idle state. So here you can see, when we reach the final state, we are resetting it to the initial state. Here is the state transition table, where P, Q, R and S are the states respectively, and we can see that um, the states, when the current state is not S, which was the 15 or greater than 15 rupees state, the input that was for the Kokomo or Oreo is irrelevant. So we have created an initial table without that input. So, and now after we get the output 1, when we reach the S state, we can introduce that input to decide if we want an Oreo or a Kokomo. So here is the table for the Oreo and Kokomo. Let's consider Z as the input for the snack. If Z is 0, then we'll get a Kokomo, and if Z is 1, then we'll have an Oreo. So here we'll combine both the tables, and we'll get the final table for our FSM, which is basically this. As I said before, all the inputs for the snack are irrelevant before the S state, which was 1 1, which is 15 or greater than 15 rupees. So we don't consider these inputs, because that doesn't matter to us. So when we reach this state, we take these inputs, and as you can see that if it's 0, then we'll have a Kokomo, and if it's 1, then we'll have an Oreo. Now from this transition table, we can get the equation for our flip-flops, which are these respectively. Since we have four state variables, we'll have two flip-flops. as previously was shown. Okay, thank you.